Okay, so let's do an example of a scalar line integral in order to compute the mass of a wire, which is a circle of radius 2. And this wire, if it were had a uniform density, then I could simply take that uniform density and multiply by the total length of the wire to get its mass. But in this case, I don't. I have a mass density which varies with the x-coordinate. So you can think of zero density in the middle, and then it gets heavier and heavier and heavier until I get out to here where the density is 4. It's x squared. So it's much heavier on the rim here, and so I need to actually integrate around this whole wire, and I need to integrate the mass density in order to figure out what the total mass of the wire is. So first step is parametrize the shape. If we're going to compute anything, we need to know the shape. So this is a circle of radius 2, and it doesn't matter if I go clockwise or counterclockwise around it in this instance, because this is a scalar line integral. So I'm going to parametrize this just counterclockwise as 2 cos t comma sine t. So that's the x and the y coordinate. T is going to go from 0 to 2 pi, all the way around the full circle. Now, step 2 is set up the integral. So remember, this integral is going to be, conceptually speaking, an integral over the full wire of the mass density d length, or with respect to the length. Okay? And this guy right here is equal to, we set it up, the mass density is the density evaluated at the particular point that I have in terms of t. So rho of r of t. That means if I give you a t, I get r of t gives me a point on the wire, and I plug that r of t into rho in order to get the mass density at that point. And then the little bit of length is the length of r prime of t dt. And what that does is it says if I'm varying my parameter just a little bit, I've got dt, it's a small variation in the parameter, I get a variation in the length of the wire, I get a bit of length of wire, and I have to multiply by the length of the tangent vector to say how much of the wire I get from a small variation dt in the parameter. And so I want to integrate all this up, the mass density times the bits of length, integrate that over the full length of the parameter, 0 to 2 pi. Okay, so first of all, let's see, what is rho of r of t? Well, r of t is 2 cos t comma 2 sine t. Rho is just x squared. So all I'm going to do is take my x coordinate, square it, and that's the value rho of r of t. So rho of r of t is 4 cos squared t. It's the square of 2 cos t. On the other hand, I've got my bit of length here. Let's compute the norm of r prime of t. So up here, I've done the work for you already. I take r prime of t, that's minus 2 sine t, comma 2 cos t. That's the derivative of these components with respect to t. And then I want to take the length. And if you square both of these, add them up and take the square root, you get 2. So this bit of length is 2 dt. So now I've got a regular old integral over t that I can evaluate. This is multiply the 2 and the 4, I get 8 cos squared t. Integrate that from 0 to 2 pi. You'll have to use a half angle or plug it into Mathematica, and you'll get a total of 8 pi.